Have you ever stopped and wondered how your phone just gets you? How it understands what you're saying? Or how an app can look at a sign in a foreign language and translate it instantly? Well, the magic behind all of that is something called deep learning. And today, we're going to pull back the curtain and see exactly how it's teaching computers to think. I mean, really think about these questions. How do you teach a machine what a cat is? This isn't about writing a million lines of code with rigid rules. No, this is about building a system that can actually learn those rules all by itself. And the secret sauce, you guessed it, is deep learning. And the wildest part? You are already using deep learning every single day. Seriously, every time your photo app automatically tags a friend, or you ask your smart speaker for the weather, or you use a real-time translator, yep, you're talking to a deep learning model. It's kind of the invisible brain powering so much of the tech we just can't live without anymore. Okay, so we've seen what it does, but what is it, really? How does it all work under the hood? Let's peel back that first layer and get right into the core idea. So yeah, the official definition can sound a little dense, but the idea behind it is actually beautiful. Think of it like an assembly line for understanding something. Instead of trying to recognize a cat all at once, the first layer in the line just learns to spot simple things like edges and colors. The next layer takes those edges and learns to see shapes like an ear or a whisker. And the layer after that puts those shapes together to recognize a whole face. Each layer just gets a little bit smarter, building on what the last one figured out. And that layered approach, well, that's what lets a computer think in a completely new way. It is a massive departure from how we've been programming computers for like the last 50 years. Just look at the difference here. The old way, traditional programming, is all about us, the humans, writing explicit rules. To find a cat, you'd have to write code like, if it has pointy ears, and it has whiskers, and it has fur. You can see how that would get crazy complicated and break really easily. But with machine learning, we just don't do that. We just show the machine thousands and thousands of pictures of cats and say, figure it out. The system learns the rules of what makes a cat all on its own. So, where on earth did this revolutionary idea come from? This idea of learning by example? Well, the pioneers in this field looked to the best learning machine ever created for inspiration: our own brain. So, in our brains, you've got neurons. They get signals, and if enough signals come in, the neuron fires, passing the message on. Simple enough. The artificial neuron on the right, it's called a perceptron, it kind of works the same way. It gets a bunch of inputs, but here's the key. It gives each input an importance, or a weight. It then adds up all that weighted information and makes a simple decision. Fire or don't fire. Okay, but how can a simple little switch like this actually learn anything? Let's zoom way in on just one of these artificial neurons and see how the magic happens. The process itself is surprisingly simple. The perceptron gets its inputs, and it uses its weights to decide how important each one is. It just multiplies the inputs by their weights, adds it all up, and if that number is bigger than some threshold, it outputs a 1, like a yes. If not, it outputs a -1, a no. That's literally it. It's just a tiny decision-making machine. But this is the big question, right? Can this incredibly simple on-off switch actually learn to do something useful? Anything at all? Well, let's put it to the test with a classic logic puzzle. This here is what's called an OR gate. The rule we want our little neuron to learn is simple. If either input 1 or input 2 is a 1, then the output should be a 1. The only way you get a -1 is if both inputs are -1. So our mission, should we choose to accept it, is to see if our single perceptron can figure this pattern out for itself. And here's how it does it. It starts off totally clueless, with random weights. Basically, it's just guessing. We show it an example, like -1 and 1. It calculates its answer, and if it's wrong, it just nudges its weights a tiny bit to be a little less wrong next time. It does this over and over, mistake after mistake, getting a little bit smarter with each correction, until finally its weights are perfect and it gets the problem right every single time. So that's pretty cool. A single neuron can learn a simple rule. But this is exactly where the early researchers hit a massive roadblock, a fundamental limit that almost killed the entire field of AI. I mean, what happens if the rule you wanted to learn isn't so simple? What happens when the pattern gets just a little bit trickier? This is the famous XOR problem. The rule is the output is true only if one of the inputs is true, but not both. It seems like such a tiny change, right? But it turns out a single perceptron can never solve this. It's mathematically impossible. No matter how much it adjusts its weights, it just can't do it. And this discovery was so devastating it led to an AI winter that lasted for years. So here's the crucial takeaway. A single neuron, our fundamental building block, is a powerful little learner for simple stuff. But it hits a hard ceiling. It has very real limitations. And this brings us full circle, right back to the beginning. The solution wasn't to build a better, more complicated neuron. The breakthrough was to take millions, even billions, of these simple little perceptrons and connect them together in layers. The first layer learns the simple stuff and passes its answers to the next layer, which learns more complex stuff, and on it goes. That stacking of layers, that is the deep in deep learning. And that's really the core idea here. We started with one simple neuron that couldn't even solve a basic logic puzzle. But when you connect millions of them together in these deep layers, some kind of intelligence just emerges. An intelligence that can recognize faces, translate languages, and maybe even create art. So it leaves us with this incredible question to think about. If one neuron is just a simple switch, what other amazing, complex abilities are just waiting to pop into existence when we connect millions or even billions more?